మరి ఈ రోజు ఎపిసోడ్లో సీనియర్ ఇంటర్లోని వేవ్ మోషన్ టాపిక్ గురించి తెలుసుకుందాం.
Dear students, welcome to KABTV ENET classes. Today let us discuss the first chapter of your second year course, intermediate course, that is wave motion. This chapter has a weightage of about 8 to 10 marks. In what way the marks will be distributed? One LAQ plus one VSAQ. Or one SAQ plus two VSAQs, like that. In this way it will be distributed. So definitely LAQ or SAQ or VSAQ will be there from this chapter. Now, as in the textbook there are some 6 LAQs. There is a scope of getting definitely one LAQ from this chapter. Let us discuss those LAQs now in an order. The first one is formation of stationary waves. This formation of stationary waves in stretched strings is there, open pipe is there, closed pipe is there, and you will find this in 3 LAQs. Now, first let us discuss stationary waves, then we will see how these waves will be formed in strings, then open pipe, then closed pipe. What do you mean by stationary wave? A brief introduction is required. How a stationary wave will be formed? When two progressive waves of same wavelength, frequency and amplitude, these waves travel in opposite directions. Along a straight line, superimpose stationary waves are formed. So you require 2 progressive waves, maybe longitudinal or transverse, that you know. And diagrammatically, if I represent, if I take a string, when you plug the string at the middle, a progressive wave is set up at one end. That progressive wave is transverse wave, as I am taking string as an example. This transverse wave travels, moves to the other end, where at the other end it cannot advance as that end is rigidly fixed. That wave reflects and moves back, and these 2 waves have same origin, therefore they will have the same wavelength, same frequency and same amplitude. They superimpose and you are going to get a stationary wave. Due to persistence of vision, how does this wave appear? This wave appears in the form of loop. This is one loop, this is another loop, like you may get 2 loops or more than 2 loops. When stationary waves are formed, why they are called so? Because these waves are confined to a limited region. They vibrate only between 2 ends. It cannot advance. That is why it is called stationary wave. In this wave, what are the different points that are formed? At the ends where they are rigidly fixed, you will get a point called node. Node is a point where net displacement is what? 0. And at the center also, where these 2 waves cross over, you will get a node, and in between you will get antinodes. These are the antinodes, the points where displacement is what? Maximum. So the displacement is maximum, those regions are called antinodes. Where the displacement is minimum, they are called nodes. And the distance between 2 successive nodes you take, two successive antinodes you take, it is half the wavelength of the progressive wave, lambda by 2. And if you take the distance between successive antinode and node, this will be half of this, it will be lambda by 4. This is what a stationary wave, and these stationary waves we have to discuss how they are formed in strings and pipes, that we have to discuss. This is the basic information regarding what stationary wave. And now let us take formation of stationary waves in stretched strings. This is the first one. What do you mean by stretched string? Different musical instruments like sitar, guitar, veena, if you observe, you will find a thin string, that is called chord, C-O-R-D, chord, stretched between two residents. Let L be the length of the string. This is the L be the length of the string. And when this string is plucked at the middle by applying an external periodic force, what happens? You know, in strings, the progressive waves so formed are transverse progressive waves, because the particles vibrate perpendicular to the direction of propagation. As you plug the wire, the particles on the string start vibrating perpendicularly, and a transverse progressive wave is set up at the end A, and that will travel from A to B. At B, as it cannot advance, it reflects back and reaches to B, like a transverse progressive wave will be formed. This is a transverse stationary wave. This is due to superimposition of transverse progressive wave. And if the string vibrates like this, at this end you are getting a node, at this end you are getting a node, at this end you are getting antinode. These are the minimum number of nodes and antinodes that you can get in a string, and this is called first mode of vibration. This is first mode of vibration, and the frequency of the string vibrating in this mode is called fundamental frequency. This is the minimum frequency, that is why it is called fundamental frequency. Minimum frequency means minimum number of nodes and antinodes, because both ends of the string are fixed. Definitely here one node is formed, here one node, at the center as particles are free to vibrate, because I said antinodes are the points where displacement is maximum. So here at the center definitely you get one antinode. This is the minimum case, that is why this frequency so obtained is called fundamental frequency. Now we have to obtain formula for fundamental frequency. What is that formula for fundamental frequency? We know whenever a wave advances in a medium, the formula is V is equal to n lambda, where n is what? Frequency, lambda is wavelength, V is velocity of the wave. Then what is velocity of transverse wave?